Chapter 6, we're going to do applications of our normal distribution curve. So same idea that we worked on the first section, we're just going to go a couple steps further, basically apply this to real world situations or to some word type problems, some application problems. To solve problems by using the standard normal distribution, transform the original value to a standard normal distribution variable using the following formula. This is a z-score. Z-score is the value. Let's just try that again. That didn't work out very well for us. Something that might be a little bit more legible is the value minus the mean divided by the standard deviation. Just making one quick point here. If you're using a graphing calculator, which most of us are, order of operations is applied there. So if we're going to type that all in at once, you need to type your numerator in parentheses, so it does that difference and then divides it by the standard deviation. Okay, once the z-score is found, we use the inequality statement from the problem as well as our table E from the pull-out section of our book. It's also on the front cover in our book. It's also in the appendix in the back. So there's 3 different places you can find table E. We'll use table E to find that area or that probability, just like we did there in that first section. So here we'll start out with a quick example. Mean number of hours an American worker spends on the computer is 3.1 hours per workday. Assume the standard deviation is a half an hour. Find the percentage of workers who spend less than 3.5 hours on the computer. Assume a normal distribution. A couple things to note out here. Obviously, our standard deviation, or S, is right here. I guess maybe we say or sigma. Standard deviation is S or sigma. 3.1 is our mean number of hours, so that's our mu or our x bar, depending on how we want to look at that, which means 3.5 is the value or the x that we're trying to work with. So to calculate our z-score, we do 3.5, which is our value, minus our mean, which is 3.1, divided by our standard deviation, which is 0.5. If we calculate that, we get a z-score of 0.8. Much like we did in the first section, I'm going to use our curve to illustrate that. Again, 0 cuts that curve in half. Our z-score is 0.8, so it's a positive z-score on this side. Then I go back here and I look and it says less than that number, less than 3.5. Our z-score for 3.5 is the 0.8, so less than that we're shading to the left. Now if we recall from our first lesson, the table that we work with, table E, measures the area to the left. So I go here to 0.8 and that z-score, or that area, is 0.7881. That is the area to the left of this z-score. So it's that 0.7881 is our probability, or because it's percentage, we might write it as 78. Let's try that again. 78.81%. Again, either one of those is the same thing, but it is our area to the left based on the information from that curve. So again, not a lot different from our first section. We're just going here, calculating our z-score first, and then using the inequality from the information of a problem to shade. A couple more here. At a certain store, the average amount spent by each customer who makes a purchase is $25 with a standard deviation of 8. Let's just stop right there and identify that as the mean, and that is the standard deviation. The customer is picked at random. Find the probability that the amount spent will be between $25 and $40. Now I'm hoping most of us would recognize this, but we do have 2 separate values here, 2 separate x's. And with that being said, one of those values is the same as the means. If I were to set up 25 minus 25, divided by our standard deviation, that's going to be 0 divided by 8, or 0. So as we mentioned in the first section, the mean is translated to a z-score of 0 based on a standard normal distribution. So our z-score for 25 is 0. We will calculate a z-score for 40 as well. So 40 minus 25 divided by 8 gives us a z-score of 1.88. And we go to our curve then. 0, as we all know, cuts the curve in half. 1.88 on this side. We want the area between those two, which means when I go to look up 1.88 in here and find that number to be 0.9699. 0.9699. That 0.9699 measures the area all the way down. We don't want the area all the way down. We want to stop here. So from that, we're going to subtract that lower half, or 0.5. So our probability is 0.4699. Okay. So moving on to letter B, more than $40. We already have our z-score for $40. So I'm going to set up our distribution, our curve. 1.88 here is our z-score for $40. This time it says more than. I'm going to hope we all agree that more than is to the right of that z-score, so 1.88. We've also already looked up the 0.9699, but as we've mentioned, 0.9699 measures the area all the way down. We want the area to the other side, so to get that area we will subtract from 1 and we'll get 0.0301. That's the area to the right, or more than $40. Less than $40 is our next example. We already have our z-score for $40, so I'm not going to calculate that again. I'm simply going to put that on our curve, 1.88. It says less than. Hoping we all agree that means less than shades all the way down to the left. Look up and get 0.9699. That's our area. That's also the area to the left. So in this case, 0.9699 is our actual answer here. We'll keep moving on here. A contractor decided to build homes that will include the middle 80% of the market. The average size of homes built is 1,810 square feet. Find the maximum size of homes that the contractor should build. Assume the standard deviation is 92 square feet, and the variable is normally distributed. So up here, 1,810, that is our mean. Middle 80%, that's our area or our probability. So if you kind of take a look at that, we're working backwards here. We'll start with our curve. We're trying to find our x's. When we have our z-score, we're trying to find that maximum minimum value, so that's twice. We're given our mean, given our standard deviation, so we have to work backwards from our curve. So here, 0 is in the middle. The middle 80% then would go 40% on this side, or 0.400, and it would go 40% on this side. We want to find the z-scores that go there. And once we have those z-scores, then we can calculate our x's, because we'll know three of our four variables. So 40% is on each side, or a total of 80%, which means outside here in both tails of this side and this side, is a total of 20%, or 10% on each side. 10% on this side and 10% on this side. So if I started here, I could go to my table. The area under the curve is 10%, or 0.1000. I could work backwards to find my z-score. So I'm going to pull up the table here, go inside the table. We have to go to the negative side of this, and we're going to find the value closest to 0.1000. So as we move across here, notice I have 0.985 here and 0.1003 here. I hope we would all agree 0.1003 is much, much closer than 0.0985. So I work backwards from my z-score. It's 1.2, and we go to the top, 8. So 1.28. That's my z-score, negative 1.28. Pulling back up my notes here, my z-score on this side is negative 1.28. The good news is, because we have 40% on each side, my curve is symmetric, so my z-score on this side is positive 1.28. So now taking that to my z-score formula, up here, my z-score is negative 1.28. I don't know the minimum value, but I know the mean is 1,810, and I know the standard deviation is 92. Let's go ahead and go through the simple algebra on that. The first thing we would do is we would multiply both sides by 92, and that would give me 117.76 on this side equals x minus 1,810. I want to solve for x, so I'll add 1,810 to both sides. and that will give me a lower end to this spectrum of about 1,692 square feet. So there's our lower limit. I'd repeat the process for the upper end. I have a z-score of 1.28. That equals x minus 1,810 divided by 92. I'll skip over the algebra involved here. Most of us should be able to do that. 1,928 square feet. So there's our maximum and our minimum values that our contractor should build for houses based on the middle 80%, somewhere between 1,692 and 1,928 square feet. Let's try a few more here. The mean time to complete a certain psychology exam is 34 minutes with standard deviation of 8. What is the probability of a student taking more than 28 minutes? Z-score for 28 minutes. 28 minus our mean of 34 divided by 8 is a z-score of negative 0.75. Going to my curve, I'm going to put 0 down the middle. Negative 0.75 is on this side, and it says more than, so I'm going to shade to the right, which means when I look up negative 0.75, so 0, 1, 2, 3, 4, 5, I get 0.2266. That 0.2266 is the area to the left of the curve based on our table. We want the area to the right, so we will subtract that area from 1 and get 0.7734. There's our probability of taking more than 28 minutes. Our second one here says between 15 and 28 minutes. We already have a z-score for 28, so we just need a z-score for 15. So 15 minus 34 divided by 8 is going to get me a z-score of negative 2.38. So on my curve, we'll put 0 here, negative 0.75 here, and negative 2.38 here. Our phrasing says between those two. I've already looked up negative 0.75, that's negative or 0.2266. I'll go back to my table and look up negative 2.38. I need to scroll up here a little bit. Negative 2.38 is 0.0087. So I'll plug that in here, minus 0.0087. Hopefully we recall from our work there that we subtract our work in section 1, 0.2179. Oh, we have a third problem here between 28 and 41 minutes. Again, we already have the 28, so I'm going to calculate a z-score for 41. 41 minus 34 divided by 8 is 0.88. On my curve, my z-score for 28 minutes was negative 0.75. My z-score for 41 minutes is 0.88. I want to be between those two. We'll look up 0.88 first. Oh, I have to scroll down to the positive side here. 0.88 is right here. 0.8106. 0.8106. We're fine between, so I subtract out. I've already looked up negative 0.75, 0.2266, and when I subtract those, I get 0.5840. And then finally, our last one with our psychology exam. If 100 students took the exam, how many should finish in less than 30 minutes? We'll calculate our z-score for the 30 minutes, so 30 minus 34 divided by 8 gives me a z-score of negative 0.5. We'll find our probability first. 0 here, negative 0.5. It says less than, so we're going to shade to the left. If we go to look up that number, negative 0.5 is right here, 0.3085. And 0.3085 is our probability, but this one says 100 are taking the test. So I take that times 100 students, or would expect 30.85. Or we might, if that were a minimum number, we might just say 30 students are going to take that test in less than 30 minutes. I think we have 2 more to complete this, so let's take a look at those. These are going to be 2 that are working backwards, I believe. Pizza restaurant delivers in a mean time of 18.2 minutes with a standard deviation of 3. I'm just going to pause right there and mark that as the mean, and mark that as the S, just so we have those, maybe S or sigma. They want to advertise, they will not charge for pizza that takes longer than a certain length of time to deliver. If they want to give away pizza no more than 5% of the time, how many minutes should they claim they deliver in? So notice we don't have that how many minutes, that's our X that we're trying to find, so X, which means I probably want to start with my curve here. I'll put 0 in the middle. That's the same thing as our 18.2 minutes. Okay, so there's our mean time that we take to deliver. If we want to give away pizza no more than 5% of the time, that means somewhere out here, say 30 minutes is what we're going to advertise. Right here is the 5% of the time we give away a pizza. And we recall that 5% is a decimal 0.0500. Now our curve, table E, measures the area from our z-score to the left. So I'm not going to look up 0.000500, I'm going to look up 0.9500, 1.0 minus that. Okay, so I'm going to go inside my table here, have to go down to the positive side, find the value closest to 0.9500, which is going to put me right up in here. Notice these two are the same distance away. We talked about this in the first section. We'd like to use a larger absolute value, so I plug that back out. 1.65 is my z-score. So 1.65 is my z-score. I'll plug that into my z-score formula. 1.65 is the z-score. We're trying to find x. We know the mean is 18.2 minutes, and the standard deviation is 3 minutes. Multiply both sides by 3, add 18.2 minutes to it, and we get 23.15 minutes. So our pizza delivery company can advertise they deliver in a little over 23 minutes, probably would round up to 24, and they shouldn't give away a pizza any more than 5% of the time based on previous experience. So one more time, just to make sure we're crystal clear on that idea, a teacher gives a test and the results are normally distributed with a mean of 36. So there's our mean and our standard deviation of 5. There's our sigma. If the teacher wants to give the top 10% of the class A's, what should be the cutoff for an A? I'm going to start with our curve here. 0 is our mean down the middle. Our mean is also an equivalent score of 36. The top part of the class gets A, so that would be on this side. This is the top part of the curve. This part is 10%, or as a decimal, that's 0.1000. Again, our curve measures the area, our table, measures the area from here down. So I'm going to go to my table and look up a z-score for the decimal closest to 0.9000. So I go inside here, 0.9000 is going to put us right in this area, 0.9015 or 0.8997. I'm hoping we all agree that 0.8997 is closer, so I work my way back out. I have 1.28 here as my z-score. So 1.28. Plugging that into our formula to solve, 1.28 is our z-score. We don't know the value. We do know the mean is 36, and we know the standard deviation is 5. If we multiply both sides by 5 and then add 36 to both sides to get x by itself, our mean or our average, our cutoff for an A is 42.4. And there's a take a look at our application problems for the normal distribution curve.